last homework before our midterms, and it's about neural networks again. We will try to make recognizing algorithm here as the other one. In the other one, we will try to make it just for number 0. Here, we will try to do it for digits from 0 to 9. As always, first we are importing important packages because of I couldn't import as the other ones the IPLY MPL file. I just use pip installation here. After that, we are starting with learning what is real function. Uh, Real function returns uh, returns Yeah, it returns if it's a positive number, it returns its own value. If not, it returns 0. So, let me can I show you something right here? So, if there is a coordinate system, it becomes something like that. So here, Z, this is the GZ. Okay. And about the softmax function, a multi-class neural network generates and outputs one of these selected as a predicted answer. In the output vector, Z is generated by a linear function which is fed into the function. Softmax function converts Z into a probability distribution as described below. The larger inputs to the softmax will correspond to larger output probabilities, and as you guessed, truly, some will be 1. So, I mean, if there is a sample and one output is from the softmax function is 0.3, the other one is 0.5, the last one becomes is 0.2. Their summation must be 1 because it's a probability. The total number must be 1. Okay, and this is actually not a linear function. Why do we need linear functions? Because our neurons are going to work like that. We cannot, for the hidden layers, we cannot use, where is painted? Well, we have some of layers like that with neurons. So for the last one, we can use linear function, but in the layers between before the last layer, we couldn't use actual linear function because it becomes normal regression, logistic regression, which is not needed a neural network. So here I wrote the um, uh, code code of this function as numerator and denominator. What is A? A is division division of these things. After division, after creating our method, uh, we are we are we are showing the my function is the TensorFlow function has the same result. It means my method written correctly. If my softmax and TensorFlow softmax is gives same results, it means my definition is correct. So after seeing our function is correct, we are continuing with learning some other new things. We made a binary classification for zeros. If it's 0, it returns 1. If it's not 0, it returns 0. So, but here we have 0 to 9 numbers. We have 10 classes. We need to make I forgot the name. This type of, multi-class classification task. So we will have 9 groups in here. So for example, for 0, x1, for 1, x2, for xm, it's 9, etc., etc. So if y is 0, it returns 0. Yeah, it explains same thing with me. First, we are loading the data set, as always we made. After loading data set, and seeing data set values here, we are checking their shape because shape is important before creating our model, because we will use this shape in actually in a matrix multiplication. So we need to see the uh, dimension to make this uh, matrix multiplication. So in the cell below, the code randomly selects 64 rows, 20 pixel by 20 pixel grayscale image, and displays the image together. Unfortunately, we couldn't see the image here. And because of widget manager is not working correctly in Colab, we need to open it in Jupyter Notebook. Anyway, we have here, let me check images. No, not that one. I think we don't have here. Okay. Model representation. It explains what kind of model we are gonna create. We will use 25, 15, and 10 dimensions for our neurons to give results. And we will use model fit to fit our model. So yeah, here we created our dances and um, for, as you see, we are using activation functions relu in the before neurons. Uh, in the last neuron, we can use linear function. It's not like matter. It doesn't matter. Um, this code part doesn't work as the other one. I don't know why. And after that, we are getting weights. Because we will use this phrase in our uh, algorithm, in our model. Uh, After that, we are confining our model with sparse categorical cross entropy, and we are giving a learning rate. We can change to get different results to get this learning rate. And we are using 40 epochs here. If we use more epochs, it's gonna give us more uh, better model actually. So we can test it. We can test it in 40 epoch. Let's see how many loss we have here. 2.27, and in prediction, let's see. Where is the prediction value? Yeah, 33 errors we have. Let's change the epoch size here and then try with, for example, 60 epochs. But there is a problem that we can make an overfitting here, and it could be worse than 40 epochs. So I didn't beat 18, 100, or 1000. I didn't do something like that because I don't want to make it overfitting model. Or I didn't beat 10 because it could be underfitted model. So I used a closer number like 62, which is closer to 40. But I don't know if it's gonna work better or it's gonna be overfitting. So let's check it. It's an experiment. Uh, as you know, it was 2 point something here, 1.73, but this loss is not really matter. The important one is uh, here. Important one is error number here. So we will see after this step. Now it's working on our images. It finished. Now let's see how many errors we will see. Zero errors out of 5,000 images. As you can see, 60 epochs works better than 40 epochs, but if we made it like 80 or something, it could be overfitting. So we need to be really careful changing epoch size or something. Yeah, this is the last of our homework. Thanks for watching.